Hello and welcome to yet another new video of phone knowledge. So in this video I am going to derive some of the formulas of chemical kinetics. So you are very much familiar with these formulas. For zero order this and half-life, for first order this and its half-life, for second order this and its half-life. So I am going to integrate and derive these formulas. So first I am going to do zero order. Okay. So initially A is the product and P initially A is the starting material, and after a time you are getting a P product. Okay. So let us consider at time t0 you are getting A0, that is the initial product. Okay. At time t you are getting a product, final product after time t. So how to determine its rate? Its rate is written as minus dA by dt, okay, is equals to K A0. A0 because it's a zero order reaction, that is, it is K. So it is the rate of zero order. So now I am doing integrating both sides, that is, its upper limit will be AT and lower limit will be A0. So we will integrate dA okay. So on integrating this we will get this one. We know upper limit minus lower limit, so, and as minus sign is present I am doing it in positive way. So A0 minus AT will be AT. On integrating dt with respect to 1, it will give you T. So this is the derived formula. Okay. So now how to obtain half-life from this reaction? I am considering it as 1. Okay. So I am erasing this part. I hope it is clear how to derive this formula. Now I will obtain its half-life from this reaction. At T half, initial product will be by 2. So on putting this value here, what we will get? We will get T half, that is so from here you can see T half is proportional to A0, that is we have obtained this formula. So this was all about zero order. Now I am moving on to first order. Similarly, at time t equals to 0, initial product is A0. At time t equals to t, initial product is AT. Okay. Now, what will be its rate? Its rate will be minus dA by dt will give you k a to the power 1 as it is the first order reaction. Now on integrating this one, upper limit will be AT and lower limit will be A0. On integrating this, we will get log ln AT by A0 equals to minus AT. Okay. So on moving this ln to this part, you will get e to the power minus kt. So I am doing it here. At equals to A0 e to the power minus kt. So now see, we have obtained this formula on integrating the rate. So this formula is obtained. Now we will get its half-life. Okay. I hope it is clear. I am erasing this. Now regarding this as equation 1, I will get this half-life of first order. So similarly, T half equals to A0 by 2. On putting this value at 18, I will get A0 by 2 equals to A0 into e to the power minus kt. Okay, so by mathematically solving this, we will get T half equals to 0.693 by k. Okay, here it will be a log and some number. On solving this, we will get 0.693. So from this, we will get this. So this is the half-life of first order reaction. So I hope it is now clear. Now I am moving to second order. So similarly, the first part will be same. At time t equal to 0, initial product will be written as this A0. At time t equals to t, it will be written as AT. Now what will be its rate? Its rate will be minus dA by dt, which is equals to Ka2. Why 2? Because it's a second order reaction. Now on integrating this, the lower limit and upper limit will be same, AT, A0. Here it will be dA by A2 equals to minus K T0 dt. On integrating this, we will get this formula, that is 1 by AT minus 1 by A0 equals to AT. I have moved this negative sign in the left hand side and we will get this formula. Making this formula as equation 1, we will obtain this half-life of the second order. I am erasing this part. Similarly, T half is equals to A0 by 2. On putting this here in this equation, that is 1 by A0 by 2 minus 1 by A0 equals to KT. You will get 2 minus 1 A0 equals to KT, which is T half. So this one will be T half equals to 1 by K A0. Here K is a rate constant, so from here you can see that T half is proportional to 1 by A0. So this formula is proved. So I have proved all this formula by doing integration. I hope you have understood. So if you like the video, do comment, share and subscribe, and thank you.